Morning everyone. Today my topic is about describe the properties and pin configuration of op-amp. I am G Naresh from ECA section, which is the PPT of IC application subject. Let's get into the topic. Firstly, what is an operational amplifier? An operational amplifier is an analog circuit that takes a differential voltage input and produces a single-ended output. This operational amplifier is used for different operations like differentiation, integration, and inverting input signal and non-inverting input signal, addition of signals, subtraction of signals, and etc. operations. This op-amp is indicated with IC 741, means IC 741 is used for this op-amp, which is operational amplifier. Operational amplifier usually have three terminals, two high impedance input and low impedance output ports. So this op-amp has three terminals total, in which two are input terminals and one is output port. These two high impedance inputs are inverting input, which is denoted by minus, so that the output will be inversion of the input signal, and non-inverting input, which is indicated for positive signs. And operational amplifier works to amplify the voltage differentiation between the two inputs, and which is usually useful for a variety of analog functions, including signal chain, power, and control applications. This is a pin configuration of IC741, which is used in metal can and dual inline package and flat type also. But here we are widely using in dip package only, that is dual inline package, so that here it has 8 pins. The first pin is the offset null and the second pin is inverting input as mentioned previously. The third pin is the non-inverting input. These two are the inputs, high impedance inputs, and the output pin is at pin 6, which is the amplified output is taken at the 6th pin, and then this minus voltage, that is DC voltage to the op-amp, that is negative DC voltage is applied at the 4th pin and the positive voltage is applied at the 7th pin. The 8th pin is no connection, so that we are not connecting any components to the 8th pin. And then the 5th pin and 1st pin are the offset nulls. So the pin configuration, which are about these pins we will learn in detail. So the pin configuration, pin 4 and pin 7 are power supply pins. So this pin 7 is a positive voltage supply terminal and the pin 4 is a negative voltage supply terminal, and pin 6 is the output terminal. This is the output pin of the IC741. So the pin 2 and the pin 3 are the inputs. These are the input pins of an integrated circuit, and the pin 2 is the inverting input and the pin 3 is non-inverting input. In inverting input, the output will be the inversion, that is 180 degrees out of phase with respect to the input. And in the non-inverting input, when we apply a signal to non-inverting input, then the output will be 0 or 360 degrees in phase with the signal, so with the input signal. That's why we are using pin 2 and pin 3 signals pins, and then pin 1 and pin 5 are the offset nulls. These offset nulls are used because of the high gain produced by the 741 op-amp. Even slight difference in the voltages at the inverting and non-inverting inputs caused due to the irregularities in manufacturing process or external distributions can influence the output. So by this, the irregularities in manufacturing process or external disturbances occur. So to overcome this, pin 5 and pin 1 are used as the offset nulls. In some applications we are not using this offset nulls. In only some of the applications we are using this offset nulls. And the pin 8 is the no connection. So this pin is not connected to any circuit inside the IC 741. It's just a dummy lead just to fill the void space in standard 8-pin packages. We have only standard 8-pin packages. We not have 7-pin packages like that, so that to avoid the space in standard 8-pin packages we are using this pin 8, which is no NC, that is no connection. Ideal characteristics of op-amp. Hence we have seen the pin configuration, then we are going for the characteristics of op-amp. In these characteristics we have two. One is ideal characteristics, another is practical characteristics. So ideal characteristics. An ideal op-amp is usually considered to have the following characteristics: infinite open loop gain, G is equals to V0 by Vin, and infinite input impedance Rin, and zero output impedance. So that this op-amp has open loop gain, that is V0 by Vin is the gain, so it has infinite open loop gain. The open loop gain is very high and the input impedance also very high, and the input current is 0, and it has 0 offset voltage and infinite output voltage range, and infinite bandwidth with 0 phase shift, and infinite slew rate also present in this ideal op-amp. The slew rate is when we change the input automatically with respect to the input, the output also changes, that is called the slew rate, so that it has infinite slew rate, and it has output impedance is 0. Hence the for op-amp the input impedance is infinity and the output impedance is 0, and the infinite output current range, and it has no noise, and it should have infinite CMRR, that is common mode rejection ratio, which is the AD by AC, that is differential gain by common mode gain, and the infinite power supply rejection ratio PSRR. It should have infinite power supply rejection ratio. And when come to the practical op-amp characteristics, power supply requires a minimum voltage of 5 volts and can withstand up to 18 volts. So the power supply is minimum of 5 volts and the maximum power supply is 18 volts, and input impedance is about 2 mega ohms. Hence we previously discussed in the ideal cases it is very high, that is infinite. So hence practically the infinite impedance is not applicable, so that we are considering the practical has 2 mega ohms, and the output impedance is 75 ohms. In ideal case it is 0, and the voltage gain is 200k for the low frequencies, 200 volts per millivolts, and maximum output current is 20 milliamps. Hence it is 0 in the ideal case, and recommended output load is greater than 2k ohms, and the input offset is 2 millivolts to 6 millivolts. It is 0 in the ideal case, and the slew rate is 0.5 volts per microseconds. It is the rate at which op-amp can detect voltage changes. So in the ideal case of slew rate we have seen that it is infinity. So in the practical case we are seeing it as 0.5 volts for microsignals. Thank you.